and yeah, and then we'll see what's the use of that. So magnetic. So you guys already know the Coulombic force, right? And then we have this magnetic force. So before that, let us do this centripetal force. Okay. So in centripetal force, what's uh, what is happening in centripetal force? Till right. So what is the meaning of centripetal? Do you guys remember? Hmm. Do you guys remember what is the meaning of centripetal? It means center seeking, right? So you have a certain motion, and the acceleration is always, let's say this is the center. Oh, the acceleration is always towards the center. Good. It's good that Saad has also. Assalamu alaikum, Saad sir. Right, right timing, sir. We just started.
Walaikum salam, sir.
Yeah, so we just started. Okay, so we are just talking about centripetal force, right? So centripetal means center seeking force, right? So force is in the direction of acceleration, right? So the acceleration in centripetal force is always towards the center. So this centripetal force is always towards the center, right? And velocity is tangential to it. So this is an example of uniform circular motion, right? So what does this centripetal force do? It binds the particle or object, or it confines the particle in this circular motion, right? And why we are saying uniform circular motion? Why is that uniform circular motion? Do you guys remember? Yes. Why is it uniform? What is uniform motion, guys? What is uniform motion? Hmm. What is uniform motion? Yes, so it moves in uniform path. What is a uniform path? What is a uniform path, Mariam?
Covers equal distance and equal intervals of time.
Yeah, so this is that is what? That is equal. If it covers equal distance in equal interval time, so that is uniform speed, right? Right? Speed is constant, right? Speed is constant. So for uniform means same or constant, motion means speed, right? What you guys say, what you guys can say that the velocity direction in at this point is in this direction, and velocity direction is at this point, tangential. So you guys will say that the velocity is different, right? Am I right, guys? So at this point, velocity is in this direction. So they are not equal vectors, right? Correct, guys?
Yes, sir.
but the magnitude of the velocity at each point is constant, is same. So that is why we are saying that the motion is uniform, right? So that is why we say it as uniform. Circular means that it is confined in this circle. So uniform circular motion. And the velocity is related with the angular velocity as omega r, right? And acceleration is how much? Acceleration is how much, guys, for the uniform circular motion? Acceleration is v square by r, which is omega square, and centripetal force is mv square by r. So this is what we call the uniform circular motion. Uniform means that constant speed, but the direction is changing. At each point, direction is changing, but what? But the magnitude is always the same. Okay, and because of the direction is changing, so you have some acceleration, and that acceleration is v square by r, which is omega square r. And this force is always directed towards the center. That are the few things that I wanted to tell you guys. Just the revision part. So this is centripetal force in a uniform circular motion. Okay, so do you guys remember now? Now, what is the use of these? So we'll see that at some point later. We'll see that. Okay, and yeah. So now, what is magnetic? Okay, so we have some direction of magnetic field, right? This is like this. So what is this direction? What is this direction, guys? Can you guys tell what is this direction? Yes. What is the direction of magnetic field in this case?
And
Yeah. So this means that, yes, good. So this means that, okay. So I'll have to print my. Yeah. This means that all the magnetic field are going right in what direction? So in every point, at every point, the magnetic field is going inwards. So magnetic field, as Aisha said, is inwards. Okay, and what is happening is that some charge is traveling. So we have this Q charge, and it is traveling. Okay, so with some velocity, right? So what is happening is that so what is happening is that this charge will experience, due to this magnetic field, this charge will experience some force. Okay, and that is called the magnetic force, right? So this is equal to Fm, this is equal to Q, right? And V cross. Okay, so this is called the magnetic force. Whenever a charge is moving in the presence of some magnetic field, so it will experience some force due to this magnetic field, and that is called the magnetic field. So if I ask you guys that what is the angle between force and velocity, so can you guys tell? Guys, what is the angle between force and velocity? Magnetic force and velocity. Yes. what is the angle between magnetic force and velocity? Okay, so if I ask you that, I have a vector, let's say r, and this is a cross b, right? So what is the angle between r and a? This we have learned already. That's why I'm asking this. So what is the angle between r and a? Yes, whenever we take the cross product, so direction of cross product, how do we calculate? So this is a, this is b, right? And we are calculating a cross b. So what would be the direction of a cross b? This is given by what? This is given by what, guys? Okay, so I have this a, right? This is a, and I have this b, right? So this is some angle, okay? So this is a, this is b, and this is the angle between them, theta. So if I ask you that, what is the direction of A cross B? How do we calculate that? This we have done it already so many times when we were doing vectors, cross product, and then we were doing this just recently. So yes, guys, do you guys remember in the Biot-Savart's law extensively we did this? Okay, so let me revise this. So what we do is that we place our palm, right, in the direction of this A, and then curl our fingers. So whatever this thumb points out, so that is called the direction of A cross B, right? So we have seen it in the example of I cross J. So what does I cross J gives? Yes, what does I cross J gives? Yes, I cross J gives what? K, right? So we have this, right? We have this three vectors. Okay. So we have this I, this J, and then behind this is K. So all these three are perpendicular, right? So all these three are perpendicular to each other, right? So if I calculate I cross J, so it will point towards this K, right? So I cross J is equal to K, and K angle or K vector is perpendicular to I as well as perpendicular to J, right? So this R vector, this is perpendicular to A, and this R vector, this is perpendicular to B. This is what I wanted to tell you guys. So is this clear? Okay, so without, yeah, so let me directly write. So the direction of magnetic force would be perpendicular to B, and this would be perpendicular to this magnetic field. And how do we calculate the direction? Using vector cross product or Maxwell's right hand thumb. So this we have done, so I'm not focusing on that. Okay, so this is what the magnetic force is. F is F is this is Q, and V cross, right. So there can be different scenarios. One would be that one is that the so this is my magnetic field, right? And charge. So here is the charge, right? And it is also moving in the same direction. Velocity is also inwards. Okay. So V is uh, right parallel to. Okay, so if V is parallel to B, which means that what is the angle between V and B? Theta is how much, guys? Theta is how much? Theta 90. Both are parallel. So this is V and this is B. So what is the angle between V and B? Yes. So 0 degree, right? Yes, correct point. So theta is 0, right? So magnetic force would be how much? This would be Q and VB. Let me calculate the magnitude on it. So this is VB sine theta, right? Because A cross B is AB sine theta. Okay. So this is how much? Theta is 0. So QVB sine of 0, which means that this is 0. So magnetic force would be 0 when velocity of the charge is parallel to this magnetic field. Understood? Clear, guys?
Yes, sir.
Okay. Now, so what are the attributes of this magnetic force? Okay. So you guys know that. You guys know that the displacement, right? So displacement is S is in the same direction as F, right? Okay. So okay, not this one. So this is okay, so is same direction as velocity, right? So if this displacement S is in the because the this is moving in this way, right? So this is the velocity. So displacement will be also in the same direction, right? Understood, guys? Is this clear? If this is the velocity, then displacement would be again in this direction. So we know that force is perpendicular to velocity, right? Which means that force is perpendicular to displacement. Is this clear? Is this clear, guys?
Yes.
Okay. So, and we are not talking about uniform circular motion because in uniform circular motion, the displacement and velocity are in different directions. But we are talking about, let's say, in this motion. Okay. So this is equal. Then what is the work done? Work done by magnetic force. So work done by magnetic force would be what? This would be this W would be F dot N. This is the work done, right? Who got disconnected? Aisha got disconnected. So let her come and then we'll move ahead. So what is the angle between F and S? What is the angle between F and S? Yes, guys. What is the angle between F and S? 90 degrees. So theta is 90 degrees. So this is Fs cos of 90. So this means that work done is zero. So work done is zero for the case of this magnetic force, right? Work done is zero for the case of this magnetic force, and from the yeah. So let her join. Okay, Aisha, you got disconnect. So we are just discussing the work done by magnetic force. So we know that this force is perpendicular to this displacement, and if we calculate work done, so this is Fs, right? Force into displacement. Then theta is 90, so work done is 0. And what is work energy theorem, guys? What is work energy theorem? So guys, quickly tell me what is work energy theorem? W is what? Change in kinetic energy. This is half and mv final square minus half mv initial square. So this is W. This is 0, which is half mv final square minus half v initial square. So cancels and we have v final equals to v initial. So for the case of, so this represents uniform. Okay. So in the magnetic field, right, in the presence of magnetic field, the work done is zero by that magnetic on the charge. Okay. And the velocity will be equal, right? Magnitude of velocity would be constant. So these are the few results of the magnetic force. You guys note it down, and then we'll talk, yeah, and then we will go ahead. You guys quickly note it down. And whenever you guys want me to scroll down the screen, or if you have yeah, should I scroll down, guys? Yes, everyone, should I scroll down?
Yes,
Okay, so in here, the magnetic field is going in magnetic fields. And whenever you guys have noted up to this point, so please tell.
Done, sir.
Noted, guys. Noted. Yes, noted up to this point. Whenever you guys have finished, please tell. Noted, guys. Everyone, noted. Okay, Okay, so now the next case is second case is V is perpendicular to this magnetic. Okay, then what will happen? So we have this when we have this magnetic field. And then what do we have? So the charge is firstly it is this is the charge. Okay, and the velocity would be in this direction, right? This is the velocity, and magnetic field is inwards. So what is the angle between velocity and magnetic field? Yes, guys. What is the angle between magnetic field and velocity? What is the direction? What is the angle between magnetic field and velocity, guys? So magnetic field is inwards. It is going inside, and this is in the right. So what would be the direction, guys? Angle. What would be the angle? Angle between velocity and magnetic field. Okay. So why you guys are so silent? So the magnetic field is going inwards. It is coming at you, right, inwards. And this is right. Okay. So you guys can see that. What is the angle between velocity and magnetic? This is 90 degree, right? So this is 90 degree. This is coming at you. It is going in the right direction. So you can see that it is 90, right? It is 90. Okay. So this is the velocity, right, in the right direction. And then magnetic field is in the inside. So what is the direction of the magnetic force? So this is the direction of velocity. Velocity is going in this direction. And then the magnetic field inside, right, inside. Then this is the magnetic force. So at this point, you guys can see that. So at this point, the magnetic field, magnetic force direction is this one. Am I clear, guys? Is this clear to you guys?
Yes, sir.
So magnetic field is in this direction. Okay. Now you guys are here. So you guys tell me that you guys the particle, the charge is here. So this is the velocity. This is the velocity, and the magnetic field is inside. So you guys tell me that what is the direction of the magnetic force? What is the direction of the magnetic force? So now what is happening is that this is charge is moving in this way. Your magnetic field is in this way. So what is the direction, guys? What is the direction, guys? Yes. What is the direction, guys? What is the direction, guys?
So can you repeat?
Yeah. So the charge is moving in this way. velocity is in this way. Okay, velocity is in this way, and the magnetic field is going inside. So what is the direction of magnetic force? Charge is going upward, right? Magnetic field is inside. So what is the direction of the magnetic? Yes, it's also about direction, right? So we have extensively discussed about all these directions. Only one thing we should know. Only one thing, and that is Maxwell's thumb rule, I direction. So I direction is in this way, right? So this is right. What is the so yes. So Aisha is saying I direction. What is Mariam and Saad? What about you? What do you guys think? Yes. What do you guys think? You guys place your palm in the upward direction and curl your fingers in the inside direction, right? And then you guys tell me that uh, what is the direction of the force, or what is the direction of your thumb, right? You are also getting. Why you guys are getting right? Okay, okay. So this is upward, right? You guys keep your palm in the upward direction and then curl your fingers inside. So what is the direction you are getting, right or left? Yes. So Aisha is getting left. Oh, so Mariam is getting left eye. Okay. So yeah, Aisha and Mariam, you guys are getting left. Yeah, yeah, I know, Mariam. So Saad, what is the direction that you are getting? Yes, Saad, sir, left, right? So the direction would be left. So this is the direction that we will get, right? F, F. And similarly, you guys check that if the particles, oh, you were doing with left hand. No, no, no. So that is Saad Maxwell's right hand thumb rule, right? So all the direction that we calculate up until now. So when we will do the induced magnetic field, induced current, so then we will use the, yeah. But up until now, we will use only the right hand thumb. So now the particle is going in this direction. So you guys will see that the magnetic force is in this direction. And when the particle reaches here, okay, this is the velocity. So yeah, you will check that this is the direction of the. So you guys can see that this force is pointing towards center, right? So what is this magnetic force? What is the force that points towards the center, that is directed towards the center? Yes,
Centripetal force.
yeah, right, right, absolutely right. So you guys can see that this magnetic force will act as centripetal force. So the magnetic force will act as a centripetal, right? Why? Because you guys saw the direction, right? Because it is always directed towards center, right? So if Fm is centripetal force, right? So Fm we know. Fm, let me write it in this. So centripetal force is Fm, right? Fm we know this is QVB. And what is the centripetal force? What is the value of centripetal force? Yes, guys. What is the value of centripetal force? You guys joined 15 minutes late, and I was also mv square by r. Yeah. So you guys joined 15 or 18 minutes late, so we will extend this class. Okay. Yes, Mariam, you are correct. So mv square by r, this cancels, right? So then we will get our radius of this circle, right? So this we will get, this would be equal to mv by q. So this is the radius of the circle, right? And then we calculate the time period, right? So this is this charge will repeat, right? So this will move periodically. So it will come here and then come again at this point, and then so this would be periodic motion. So then it will have some time period. Time period, which means that time it takes to come back at this point, right? So the time period is time. Time is distance by velocity. So what is the distance that it covers? What is the distance that it covers, guys? What is the distance that it covers in completing one rotation? Yes, yes, guys. What is the distance? The total distance is circumference of the circle, right? So 2 pi r by velocity. So this is what? 2 pi r, right? R is what? mv by v and q. So v cancels, and this is what? 2 pi m by q. So this is my time period of oscillation. Understood, guys? Any problem up to this point? Okay. And then the next thing is the angular frequency. So frequency would be what? Frequency, this is equal to nu, and this is 1 by t. Right? So this would be simply qb by 2 pi m. Right? And then the last thing, that is the angular frequency. So this is omega, right? Then this is 2 pi. So this is 2 pi and qp by 2 pi m. So this 2 pi cancelled, and this omega is qb by m. So these are the things that we need to remember. Is this clear to you guys? Clear?
Yes.
Okay. So you guys please note up to this point, and then we'll do the third case. Okay. So then we'll do the third case. And if you guys have any doubts, you guys can ask. Yeah, whenever you guys have noted it down, please tell. And you guys start revising all the chapters. Okay, whenever this is completed, so I will revise it again so that whenever the exam happens, so you guys can recollect whatever you have got so far. Noted up to this point.
One second.
Okay, then note down. And whenever it is completed, you guys have done.